Okay, so now we're in the realm of polygons. We looked yesterday at polygons in general, all the different types of polygons. Any polygon is a shape, except for circles and hearts. Anything with straight edges, straight sides, that's a polygon. So now we're going to focus entirely on triangles today. And there are two ways to classify a triangle. We classify them by their sides, and we classify them by their angles. So we're going to look first at classifying triangles by their sides. The triangle that we see probably most commonly looks like this. And this triangle, if I've drawn it correctly, as best as I can anyway, all the sides are the same length. If I were to take apart something, or if I were to even just use these markers are the same length. And if I were to create a triangle, they're all the same length. So that triangle is called an equilateral. And there's literally the word equal is in it. Equilateral. And an equilateral triangle, all sides are equal. Then we have this kind of a triangle. That would be like taking these two markers and making them like this, and then having, oh, I don't know, my sticky pad in between. Two of them are the same size. This one is not. So this triangle is called isosceles. An isosceles has only two equal sides, and that's it. And then there is one more kind. This one and there's many different ways that I can draw it. That kind of looks like a sad rock, but whatever. This is called a scalene. And I know these are some weird names. And the only one that makes sense is equilateral, because that's the one we can hear the word equal in. I can't come up with something for isosceles. I can't come up with something for scalene. So it's one of those things you're just going to have to remember. So a scalene triangle has 0 equal sides. Not one side is the same as another. That would be like taking a crayon and a marker and a ruler and making a triangle out of it. It will never have a similar side. So those are how we classify by their sides. But there's another way that we classify them, and we have to classify them both ways. The other way is the angles. Now we know angles. And I'm going to draw the exact same triangles. So this equilateral triangle, well, actually, I'm not going to start there. I'm going to start on a triangle like this. This is another one that we see quite often. What did I just make? Yeah, I've got a right angle right there. So this is a right triangle. Now, a right triangle can be, in this case, these two sides are the same length, but this one is not. This one is longer. So this is an isosceles triangle. So I could have a right isosceles. Could I have a right equilateral? No, never ever. I will never have a right equilateral triangle. Because again, if I have my 3 markers here, and that makes the equilateral triangle, if I were to make a right angle out of it, one of them has to be straight, right? There's my right angle. Not gonna happen. So you will never have a right equilateral triangle. Can I have a right scalene?
Yes.
I absolutely can. A right scalene, all that means is, there's my right angle, way longer. They don't match, but I've got my right angle. Okay, my next triangle what kind of angles do you see here?
Acute.
These are acute angles, That means all sides are acute. All of them. Not one of them, not 2 of them, all of them. It's the only way it is considered an acute triangle. What kind of triangles are acute? What did I draw here?
Equilateral.
I made an equilateral. Could I have an acute isosceles?
Yes.
Totally, absolutely. Boop, boop. They're all babies. So I could have an acute isosceles. Could I have an acute scalene?
No. Yes.
No. Nope, nope, nope. So now let's look at that scalene. La, 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 la. Let's see. These are hard to draw sometimes. There we go. So, what's one thing I notice here? Here's an acute angle. Here's an acute angle. What is this guy? Obtuse. This is an obtuse angle. So this is an obtuse triangle. An obtuse triangle, its rule is will only have one obtuse angle. There is only one obtuse angle. That's why the rule for an acute is it must have 3. Can I have an obtuse, can I have an obtuse equilateral?
Nope.
No. Look, if I have my markers here, here's an equilateral. One of them has to be, so here's 90 degrees. There's obtuse. Not going to happen. So I cannot have an equilateral triangle. What about isosceles?
Yeah.
If I have an isosceles, these 2 are the same. Maybe if I spread them out like super, 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 super far. Okay, so now they're at a right angle. Maybe if I made them even further, and then I had one long thing going in between here, could that be?
Yes.
Yes. So I could have, scaling would work. And then if I have this is technically an isosceles because I've hopefully drawn these 2 as the exact same, and this one's longer on the bottom. So I could have an obtuse isosceles. And I know that a right angle will not work. And I know that an equilateral will not work. Well, right, that's different. But an equilateral will not work with this. So you can see that each angle can be 2 different types of sides. You can have a right isosceles. You can have a right scalene. You can have an acute equilateral. You could have an acute isosceles. You could have an obtuse scalene or an obtuse isosceles. But other than that, Really can't do much. So that's it. Triangles really aren't that bad. You just kind of have to remember all of their different things. The right ones are going to be easy to find. Equilaterals are usually pretty easy to point out. So you just have to sort of stay focused on what the different types are. Okay?